All right, hello, this is Lindsay Betzendahl. I'm giving a presentation on the love of polygons. Woo-woo! Who doesn't love polygons? So we're going to go over how to create a radial tab polygon chart. I think this is a pretty interesting concept, and while maybe it's not best for the business, I think there still are some interesting use cases that we can use this for. Let's hop to it. Quickly, a little bit about me. Again, I just said I'm Lindsay Betzendahl. I'm a consultant at Health Data Viz, a small data visualization consulting company. I'm a Tableau Zen Master, a Tableau Public Ambassador. I co-lead the virtual health tug, and also founder of Project Health Viz. So while I've been using Tableau for almost 6 years analyzing healthcare data, I actually spent 10 years prior to that as a behavioral health clinician. So this healthcare stuff is very near and dear to my heart. But I really enjoy Tableau. So back in 2014 is when I started using Tableau, discovered it, used it at the place that I work, brought it into our organization. It wasn't until pretty much exactly 4 years later, I'd say, I got involved into the community and started participating in Makeover Monday. I started a blog, got onto Twitter, and actually started Project Health Viz. In 2019, just last year, I continued working on expanding Project Health Viz, getting more involved with those that work in healthcare data. I also started a community, Moms Who Viz, to support mothers around the world who are data visualization professionals and trying to connect with those individuals. I was honored to be a Tableau Public Ambassador and did a lot of speaking around the country at different tugs and other conferences. It's a busy, busy year. But that never goes to say that people who enjoy Tableau or good at Tableau or look like they're creative don't get creative blocks. So not too long ago, I was working on Project Health Viz data set, which was on prostate cancer, and it had some information on incidence and mortality rates by states for various years. So it was a relatively large data set, but it wasn't necessarily complicated, and I really struggled to figure out what to do with it. So one night I was in bed late at night trying to figure this out, and I got an idea. I had talked to some people that I knew about prostate cancer who kind of shared with me that there was a stigma about sharing some of the side effects of what happens with prostate cancer treatment, and that prostate cancer mortality has been on the decline, but 99% of people with prostate cancer live after treatment. And so that sounds all well and good, but there was this other side of the coin where folks were having some really unfortunate side effects, particularly sexual side effects, things of that nature. And so I got this idea about this juxtaposition between this great outcome, this perfection, so to speak, and then this other side of it's not really all that perfect. Like, what is? My mom's an artist, so I got the idea about the Vitruvian Man, which is a drawing by Leonardo DiCaprio. Ha! Oh, God, I don't even watch TV. Leonardo da Vinci, representing the ideal human body proportions. Obviously, the concept is there's no perfect person out there, proportional or otherwise. So I combined this information about the surgery side effects, rates, and some of that shame with this perfection of art. But you'll see the Vitruvian Man is a circle, right? There's a circular aspect that I knew I had to build. And so again, late at night in my bed, I came up with this idea and figured it out all in that same space. I was like, I gotta come up with a solution here. So this is what we're going to go over today. So it's not terribly complicated. You guys have probably heard some of these talks related to radial coordinates and trigonometry and what have you. So maybe it's a little familiar. But ultimately what I needed to do was I wanted to create this radial tab polygon. So I wanted these almost like squares to some degree around the circle. And to do that, I needed these 4 data points. So I duplicated my data 4 times in order to calculate these 4 points and get a path for them. Then I used some trigonometry and some radials to calculate various points that I needed, or calculations that I needed, and then ultimately using the X and Y coordinates, which are going to get me the coordinates for those 4 different points for each of my like slice, essentially. And that's all you need to know, those 3 concepts. So this is what we're going to go over in the tutorial. We're going to talk about duplicating the data and how that brings in your sheet 4 times. And Tableau will create a field called table name, which we'll use. And then using that, we'll create a path order field, which will help us draw those 4 points. And the unique idea about this radial tab polygon is that we'll use 3 parameters to help us adjust the inner and the outer radius, and then the spacing between these segments. And then we'll go over all the different 7 calculations we need to build this. We'll show you how to build it actually in Tableau, pulling all the pieces together, and how you can customize the radius and some of these different functions you might be able to utilize to make it a little more unique. Before we get into the viz, I'll tell you now, because I won't get back to the PowerPoint. My website's VizZenData. I blog and do other things there. Tableau Public, you can certainly follow me, see what I've been up to, and of course Twitter, ZendallData. All right, so let's hop to it. Right. Okay, gotta see my mouse. All right, so this is the viz that I created, and I just want to show you what we're getting into. So here you'll see each of these is a state. In this case, we're looking at a state for the rates for 2014, and anytime I hover over it, I get some information, and then there's some action filters that are filtering the incident rates and mortality rates in the intersection for the state. What you'll see is if I select any of these, you can see that they are little polygons. And so this, the whole viz really met the need that I was looking for to get this effect. So we can't do any of these, these different creative, crazy chart types without having a little disclaimer about don't do this in a business setting. Any type of chart, especially radial bars, petal charts, coxcombs, many of those can be prone to misunderstanding and inaccurate assessments of the values. I will say the radial tab polygon chart doesn't use length to encode a value. In fact, in this case, we're just encoding color and just, it's kind of just organizing or sorting around a circle instead of up or down or left or right. So the data is actually accurate using this. But again, it's definitely harder to compare things and do some of that type of analysis. So the examples today are going to be state. So we're going to use state going around the circle alphabetically, which is what I used in my visualization. And I'll also show an example of a month year, so using something over time, which also can be good for circular charts. Okay, but I'm also going to start with just saying you can do a donut chart. So this is an alternative. It gives you relatively the same idea, right? So here we have state, and we're looking at overall profit, and we're going around this circle for all the states. Now, you're obviously noticing that there is this slice effect. If I can hover and I get that yucky line, for one, and two, if I select it, I can actually see the whole pie chart, which is not really what I want to see at all if something is selected. So there are definitely some downsides to that. So let's just build one of those in case you haven't built a donut chart before. I know many people have, but let's do that anyway. So we're going to put state on a detail, and Tableau's automatically going to give me all this other stuff I don't want. I'm going to put profit on a color, and I'm going to change this to a pie chart. Now, it's taking basically each state and putting it around as a value divided by the 360 degrees in the circle. I sometimes like to make sure, depending on your data set, they're getting an accurate count. So I'll sometimes put on, just to be sure, a count distinct on angle. Now granted, again, these are all 1, so a count distinct of each of these is going to work out just fine. Then we're going to write in our min 0. Now this, all of this is doing is putting our chart on an axis, a fake axis at that. In order to make the donut chart, we are going to duplicate this, and now we have 2 pie charts. The second one of which we're going to take all this off. And you'll see here, I've already colored it white, but if you didn't, it's black. And we're going to make a dual axis. And so now they're on top of each other. Now, they're the same size, so this black one is in the way. But if I make it smaller, and now I can make it white, you'll see how we're getting to our donut. I'll make this one just a little, make this bigger so we can see it. There we go. And you have some flexibility in the sizing, though it's a little difficult. And then for formatting, we'll remove all of our lines, get rid of all this stuff. And hide, sync, and hide. And now we have our donut, right? So this is what we got. Okay. Let's do one more. So this is the rat sightings. This is a month year. We're looking at the month year that people in New York City saw rats. It's a big data set, so let's give it a minute. Okay, so on our detail, we want to have month year. And in this case, we're just doing a number of records for our color. We'll make this pie chart. It's already pretty big, so let's bring that back down. All right, that's looking trippy. And we do the same thing. In 0, pull that over, dual axis. We'll take all this stuff off the second one, make it white, make it smaller. There it is. Make this one a little bigger. Make this one a little bigger, a little bigger. Okay. And then we'll just change this color to something more interesting. I think we want I want plasma. Ooh, that's definitely not what I want. No, I want Inferno. And I want it to be reversed. Maybe it's Magna. Yeah, there we go. That looks good. So now we can see kind of this heat map of a donut chart essentially. So here's the winter months, summer a lot more, summer, right? We can see how there's some pattern, some seasonality here. And there you have it, right? Okay, cool. So as we've talked about, there's some limitations for this. Right, upon hover, select, the entire pie slice is selected. That's super annoying. It lacks precision formatting, so that spacing between slices and the size of the slices is really difficult. That slider for size is not very precise. And you got these 2 sets of tooltips actually you have to clean up. And the inner pie is a color, so you can't use a transparent sheet or a background image in that space. There are some good things, and you can put some text in the middle if you wanted, but you can kind of do that with the Radial as well. All right. So for the tab polygon, this is what we're going to do. And I do have some of this already on my blog that you can look at as well. So here, you'll see very clearly, instead we have these tabs. And I'll go through this in a little bit, but essentially, the benefit is that we have these different parameters we can use to change some of the formatting here. So our inner radius, which is from the center to this section, if I reduce this, say, to 5, you'll see how that gets smaller. If I reduce it to 3, right? We're closing that gap a little more. This outer radius is the distance between this section and here. So as we get this smaller, let's see if we make this, 5, for example, we'll see how. Now, granted, our axes are all changing, which is why you're not necessarily seeing it getting bigger, even though things are. So let's put this back to 1.5. We also have this space between the tabs, so this is this little gap. If I reduce this to 0.1, for example, you'll see how it pretty much closes up. If I make it bigger, 0.7, all right, let's go even 0.9, I get this bigger space, right? So this gives me a lot of flexibility and precision around how I want my visual to look. All right, so how do we set this up? So what I said is you bring in the data 4 times. Now, I did this way because honestly, I was laying in bed at the time and it was just easier for me. I was already in Tableau to just drag in my sheet 4 different times. It does the same thing as having a whole nother sheet, another Excel file or Excel sheet that has a row, a column and values 1 through 4, and then a join column that has just the value 1. And you literally can join with a calculation of 1 and it'll duplicate in the data pane instead. Either are exactly the same, essentially. And then we're going to create these 3 float parameters. As I just showed you, our radius 2, and our spacing. These are all the calculations. I'm going to show you all of them so you get a sense of how they actually work. One of the biggest things I hate is having calculations and being able to use them, but not really understanding how they're functioning. So I think it's important to understand. But these are all of them. And knowing this, you can build a ton of stuff, obviously, in Tableau. So first is this path order. So the path order is taking that table name, we brought in the data 4 times, and we're just going to say, we have to assign a point for each of them. So when it's sheet 1, then 1. When it's sheet 1, 1, then 2. When it's sheet 1, 2, 3, 1, 2, 3, we're going to make it 4. And that's just allocating the data to each of these 4 points. So we can draw, we can make a path and connect all these dots. We're going to use index, and that is going to allow us to count around this circle for each of our dimensions and assign them 1, 2, 3, 4, 5, etc. The angle is, you're going to take whatever dimension you want to have to determine these slices, so to speak, or these tabs. You want to know how many you have. So if I have 51 states, I'm doing a count distinctive state, and I'll get 51, and the fixed is going to help me no matter what happens in my filters or data. I'm counting the total that I have. And then I'm just going to divide that by 360. So again, for my state one, it's 360. It happened to be, so divided by, depending, 51. In my data set, it was actually 49 because Hawaii and Alaska, I think, weren't in it. And then we'll do the degrees. And the degrees is saying, this is one of the trickier ones. We're going to take that angle that we just created. And so the angle is, each of these around 360. So if the path is 1 or 2, then we want the angle to take its index, so its position around the circle, minus 1, or or minus the spacing. So that just brings it in closer depending on the spacing. So it's taking these 2 points and saying, just take this as the index, and then we're going to move it in a little bit depending on the spacing parameter. If it's 3 or 4, we're going to take that index and we're going to subtract 1 because we need to move it up to the same position as the prior tab. And then we're going to add the spacing. And so it's going to add it, which is really bringing it in this way. So as we're adding spacing, both these points are getting closer together. The radians is just translating the degrees into a radians function, which we can use later. The radius adjusted. So now that we have kind of the angle, which is telling us 2 and 1 and 2 want to be on this plane and 3 and 4 on this one, the radius adjusted is going to tell us if the path order is 2 or 3, then we want to extend this line. So we want to say if it's 2 or 3, I want to do the radius, remember that was our parameter value, plus the other parameter value. So if this was 10.5 plus 1.5, we're going to get 12 out here as the radius. If it's 1 or 4, if everything else, it's just going to be the radius. It's going to be that first parameter. So that is giving us that changing how far out by the radius that these points are going to go from each other. And then we calculate the x and y, which is just cosine of the radians times the radius adjusted, which is this calculation, and same with y. Okay, let me get back out of this. All right, so I want to show you each of these. So the first one was path order, which I just went over. And so again, this is what it looks like. And you'll see path order. Now we have all of our table names. And this is the example with Superstore that we're going to do first. Okay, and then for angle. So angle, remember for Superstore, we're doing the state and we're going to do profit, right? We're making that same donut chart we made earlier. So the angle, let me pull that back up. So angle is showing the 365 divided by our count of state. Now in this case, like I was saying, it's 49 because Alaska and Hawaii aren't in here. And when we take 360 divided by that, we get this 7.34. And you'll see every state has the same angle because they all have the same slice of the pie, essentially. The degrees is going to take those angles and add it based on the index. So degrees is saying we want to take the angle, which we know from the previous one is the 7.34, multiply that by if the path is 1 or 2, and remember that was on our bottom one, then the spacing thing, otherwise the other spacing. And that's going to give us the actual angle starting from 0 up. So here 1 and 2, and know that my path orders are a little backwards because I have 3 and 4 up top and 1 and 2 are on the bottom. So that's why they're not in order. So then you'll see as you're going, the angles get bigger around the circle until we get down to all the way to 360. And again, the radians is just changing that into radians. That gets us that calculation. And then lastly, this is showing how the radius adjusted works. So remember I told you the radius adjusted is basically going to show if it's, well, technically if it's the 1 or 4, which are the ones on the inside, we're just going to do the radius. If it's 2 or 3, which are the 2 points on the outer side of the circle, we're going to say radius plus the radius 2. Okay, so we have all of our pieces. And the good thing is, this is recorded. This is all in a workbook. You can download it and relook at this. So I know it's a lot if you're not familiar with it. But we're going to build this now. Okay, so we're going to put X and Y on our rows and columns. We're going to put state on detail. We don't need country. And then we're going to compute using state. And you'll see now we have our states. They're in order. And they go along a circle. But we're not quite there yet. The next part is changing this to a polygon. Okay, not there quite yet, because we have to tell Tableau, how do you want us to connect these dots? And so we want to take path order, or no, sorry, table name, there we go, onto path. Wait a minute, that ain't right either. So what's happening here is we need to sort these. So Tableau is going to sort my table name how it thinks it should be. Orders 1, 2, and then this one. Well, the reality is the way Tableau built it, this is actually the second path. This was path 1, 2, 3, 4. I have to make sure that they are in order. Now I will say, this could be helpful if you're changing your viz. You really want something that looks like bow ties. That's how you do it. But that's not what we want. We want this. And then we're going to put profit on color. Now we see this is coming together with each of our points. Lastly, we just need to format this. Take away some of our grid lines. Get rid of the other lines we have axes and hide our headers. We do not want those. And obviously we format our tooltips, something like just state, and we don't need, excuse me, this stuff. And there we have it. All right, so let's do one more time, this time with the rat one. So here we'll do the same thing. I've already built the calcs for the rat sightings. And here we want month, year, and detail. I already made a polygon. We have to do compute using. Okay, and then table name to path. Now this one luckily came in order because these table names did come over as 1, 2, 3. And then we're going to put number of records on color. And we're going to change this color. There we go. And we format it. And this is what we would get in the end. And what I do like about this is you'll see, starting from January all the way to December, you can really see these summer months kind of pop out with this color, and you can see that seasonality. Now, granted, a line chart is definitely better for that. So depending on your visualization, this may just add some value, add some pizzazz, but obviously something like a line chart will get us there as well. So here's a use case of this where actually Simon Beaumont had done this a long time ago. I actually pretty much replicated this same concept at my old job for a dashboard that was actually worked very well. But this is a concept where you could do the radial tab instead and not have to do this donut chart, so that people could select more specifically and or even like adjust your parameters. So here's another example. Now this is a little crazy, but you could do something of this nature. We're creating a new summer to show, to bring out something interesting within the data and actually adjust the radius so that something pops out. So in this case, and I already had this built, I suppose, I was going to go over it, but I decided, from what I saw earlier, the summer months had a lot more rat sightings, and I kind of wanted to draw attention to them, even more than the color. I want to pop them out. So here I just created a calculation that says if the month is between June and September, then it's summer. Otherwise, it's other. And then what I did is I just created a new radius summer calculation. So here I said, I know it looks big, but it's really not. If the summer months is summer, then I basically want to use this calculation to calculate the radius. And what I did is, we already had a calculation, which is actually right here, right? If the point was 2 or 3, we were going to, 2 or 3, which is these 2 points, we're going to take the radius plus the other parameter radius, right? Which got us here. Otherwise, it's going to be these points. So I said if it's summer, I actually want to say if it's the point 2, or if path order is 2 or 3, I want to actually double that. So I'm saying if it's 2 or 3, then take the radius, and these are the same things. These are my parameters. Then take the radius plus 2 times of the radius 2 parameter. So if the radius 2 is 1.5, I'm actually adding 3 to it. And that gets us this pop out. And I had to create a new, duplicate my X and Y and create a new one that would use that radius instead. And that gives us this little funky sunburst, I suppose. And my challenge to you would be to try this Radial tab Polygon chart, tag me on Twitter with Radial tab chart and add send all data. And I'd love to see what you guys come up with for using this method. Thanks so much.